Hi everyone, welcome back to the second video for Unit 6, Packet 1. Today we are going to be talking about vectors. Very simple concept and something that we've actually seen before, but we are going to discover in a new context. So before I dive into what vectors mean, obviously today's objective is we're going to discuss different vocabulary associated with what vectors are, connect it to what we already know about what vectors look like, and then create some transformations using vector notations, and you'll know you've learned it by being able to do all of the above. Okay, so before I jump into the definition, I want you to look at the vector here on the graph given to you on your paper. Notice that from P to Q, that this type of line is actually identified as what we would know as a ray. Remember, a ray is something that starts with a point. It doesn't have arrows on both sides. Only one side has an arrow. But because this ray is now located on a coordinate grid, this is actually known as a vector. And a vector sounds like a very intimidating name, but it's not. It basically means a quantity with both direction and magnitude or size. So obviously the direction means we're going in a certain way. The arrow denotes what direction it is. Magnitude meaning the length of it, and then size, just, you know, how much size it takes up on your coordinate grid. So as we look into what it represents, let's look at the first bullet point. A vector is represented in the coordinate plane by an arrow drawn from an initial point, that is the point where you have the dot, P, to the terminal point, and that is where you have the arrow, and that is, in this case, Q. So this vector is denoted as vector PQ. Now, we don't read this as ray PQ because this is on a coordinate grid. This is read as vector PQ. So the component form of a vector is written as vector PQ equals AB, where A is the horizontal component and B is the vertical component. And that looks intimidating, but it's actually very easy. So horizontal component we already know means things that go left to right. And vertical we already know is things that go up and down. So basically the component form of what we see here is starting from our terminal point, which is P, how much am I moving to the right in order to get to my end point here? So I moved 1, 2, 3, 4. Positive 4 points to the right. And how many points did I move up? 1, 2, 3, 4, 5, 6, 7. I moved up positive 7 points. So my vector component here is written as vector PQ is 4, 7. Because remember, 4 was the distance it moved to the right, and 7 was the distance it moved up. So instead of using H and K, this is just the smaller abridged version of what we previously did in the last lesson. Now today's work is fairly simple. The directions here say name each vector, then write the vector in component form. So I've already kind of gotten started with the first one. This vector's name is vector WV because the point is at W and it ends with the arrow at V. Okay, so how many components did we move to the right? We did 1, 2, 3, 4, 5, 6, 7, 8, 9 components to the right, which means that's a positive 9. And how many components did we move up? 1, 2, 3, up 3 components. So we are going to write this with 9, 3. Now, I forgot to mention before, please be very careful. These are not parentheses, these are not brackets, these are not braces. In all honesty, I kind of forgot what these are called. I'm going to look those up and let you know. But this is not the same as 9, 3, right? Please don't write it like that because this is a coordinate point on that graph. This tells me how much I traveled. So it's a very different type of notation. Okay, let's do one more. Let's do 10 because that looks like an interesting, actually, let's do 9. Let's do 9. So in this vector, you can obviously see that we're going straight up. Now, if I was asking you, is this a function? You would say, no, it's not a function because it fails the vertical line test. But we can say this is a vector. So this vector is vector m, n, and its component form is, well, how many units did we move left or right from m? And that's not a trick question. We didn't move any components left or right, so that would be 0. And how many components did we move up? That's 1, 2, 3, 4, 5, 6. So it's 0, 6. So in this case, it's just movement. You're just writing down the movement from one point to another in this very new special notation that we're learning today. 10 is very similar. 0 will be a movement in this one. I'm not going to give you the answer right away though, so you can go ahead and try it and check your work. Moving on to the next page, let's do an example with question number 11. It's not much more difficult, but it's just adding a little bit more on. The directions say graph and label each figure and its image under the translation along the given vector. Identify the coordinates of the image. So we're given the pre-image. I've already graphed this coordinate, and this is triangle STU. Now, we kind of did this in the previous lesson where this you could have thought of as H and this was K, right? It's basically the same thing. However, I do want you to draw the vectors associated with these coordinate points. So for S, let's look at that one first. We have -4, 2, and my vector says I'm moving horizontally left -1 and down by 5. So I'm going to go left 1 and down by 5. 1, 2, 3, 4, 5. So this, and then draw the vector, please. So SU with the arrow, this is going to now be S prime. Okay. Then we have T. So T is going to go left 1 and down 5. 1, 2, 3, 4, 5. Again, I'm going to draw the vector to show the movement. Please use a ruler if necessary for this step. And this now is T prime. And then lastly, I have U also move left 1, down 5. 1, 2, 3, 4, 5. So U prime right down here. Draw my arrow. And now I can just go ahead and connect my prime triangle figure. Okay. Please make sure to write down the coordinates of your image on the bottom. So S prime would have been -5, -3. U prime is -3, -7, and T prime is for -6. Okay, so in this case, we use the vector component form in order to create our coordinates from the prime or the image, okay? Do the same thing for 12, 13, 14. Please make sure you draw the vector lines as well. If you want to use a different color to draw the vector lines, completely fine, whatever you need to do to make that happen. And then the last example we're going to do for this lesson is number 15, which is just, again, same knowledge, just used in a reverse form. So the directions here say, describe the translation that maps each pre-image to its image in A, coordinate notation, and B, as a vector in component form. So I'm going to show you what that means. So we have two answers that we're going to need here. First, identify the pre-image. The pre-image is DFE, okay? Now, for DFE, let's find our vectors. So from D to D prime, I want to determine how did we move. I moved up 1, 2, 3, 4, positive 4, and I moved right 1, 2, 3, 4, 5, 6, 7, positive 7. Now, the thing is, I don't actually have to do any of the other vectors because I know if it's all going to move together, right? So basically I'm going to say, well, no matter where my xy is, right? I am going to move my x value up by 4, and my y value, oh, I'm sorry, did I mess this up? Yeah, I reversed it. My mistake. X is to the right by 7, and y is up by 4. And then as a vector, I would write that as 7, comma, 4, making sure I use these new type of grouping symbols here. All right, and that's it. That's all you really have to do. If you need help with that, or if that confuses you, please let me know. The next page is just review on basically everything that's been covered in the past 2 lessons, and then the next lesson, video lesson, will be on reflection on the x and y axis. And I'll see you then. Bye.